So thank you. It's great to be here. And for those who don't know me, I've been involved in the SBOM space since before it was really called the SBOM space, and have been following it pretty much as it's been evolving for the last 10 years. So I've been active with the SBOM Everywhere group inside of OpenSSF, as well as with the CISA groups. And so some of that stuff is all being woven into this right now. So I think I've got a pretty good cross-section of where we are, but I'm always ready to learn, so please grab me if I've missed something, and we can catch it forward. So just quickly, I think, is there anyone in this room who doesn't know what an SBOM is? We've got one hand. Okay, Rob. Yeah, right. Very good. Anyhow, I'm using mostly the definition that has come from the NTIA and then the CISA efforts, just to level set us, because there was a lot of differences beforehand. And there's some basic fields that are being expected, as well as the interpretation of these fields is one of the challenges we're going on right now. So one of the big questions is, where should an SBOM be created or consumed? Pretty much anywhere in either a DevSecOps loop or in the traditional software pipelining loop. This is where the information is, but we are trying to go in after the fact right now, in some cases, and so the information is not as precise. And there's also been a problem over the last few years, and we reconciled this. We started this discussion in OpenSSF, and they carried it forward in CISA, where, okay, what types of SBOMs? Because what's in a source SBOM is quite different than what's in a build SBOM. And people were all calling these things SBOMs, and everyone was basically talking past each other. So there was some work done to try to figure out, okay, well, what are the key buckets to put things in? And there's also, quite frankly, the analyzed, where someone's given a binary or someone's giving an artifact, and they try to figure out what they can about it. And so one of the, as you can see, these things pretty much correspond to the software lifecycle loop. And they're sort of logically information at certain places. And propagating that information into the SBOMs is what people are looking for in order to understand what's really happening. So as we sort of work our way through these supply chains, you have to look at when you've deployed something onto a system, what's all the things that are in your system. If you're modular about it and you start to link this stuff, we can actually get a pretty good picture of what's really going on and be able to actually understand what's in the system. And this is not where we are today. We're lucky right now if we get build SBOMs, okay? We are very lucky if we get build SBOMs. However, as you configure things and deploy things, that information may or may not let you expose vulnerabilities. And, oh, you've got a system running with these things deployed on, and there's something else deployed on. Oh, how did that get there? All of these are going to be very useful in the future, but we're not there yet. However, this is sort of where we're heading towards. So there's been a lot of evolution of SBOM formats that have been coming up. And so this is one pager. I think that I've managed to put everything I know about on it. The SPDX basically started off with a single package, or summarizing the data on single packages, and it evolved with more and more use cases. In parallel, the SWID tags, software identification tag stuff, was working on. It's an ISO standard in 2015. It was also recently re-ratified in 2021. And then we started in about 2018 with the NTIA work, having the CISA, having Cyclone DX starting to show up out of it, and getting the transparency, and then OMG was engaged on trying to create their own tool-to-tool standard. Luckily, we were able to merge between the OMG and the SPDX group, and we've managed to basically work forward from there. And the SPDX standard itself became an ISO standard in 2021. And that one pretty much has everything we need for SBOMs today as defined. However, there's a lot more use cases that people want to work with. And so it's a question of crawl, walk, run. And there's a lot of people that want to do the run cases, and there's people that are struggling to do the crawl cases right now. So we have a rather interesting maneuver, but we've also seen the executive order come out. We've seen the CISA stuff work over to NTIA, and we've starting to see the implications of the EU Cyber Resiliency Act. And so we've been basically, the Cyclone DX guys have been pretty much releasing every year with 1.6, and we've been working very hard on re-architecting SPDX so that it can be used in databases and systems of systems, so that we actually can scale go to scale. But a little bit more about that later. So the expectations that are coming in here, well, Congress in 2020, IoT Cybersecurity Act started making references to it. Same time, ANISA was also making references to an SBOM without having a good definition behind it. But everyone sort of intuitively knew, because from the hardware side, you know what a BOM is. It's your list of ingredients. And the question is, well, how do these ingredients relate to each other? And what do they have dependencies on, and so forth? And so the executive order in 2021 made it very explicit that they want to have an SBOM and mentioned it many, many times, and then also charged NTIA with coming up with a definition of it. And so that work then proceeded in pace. And we had the informal stakeholder work happening beforehand, which was a basis. And then there was a whole multi-stakeholder assessments of what do people have, where then they formalized under NTIA what they considered to be a minimum SBOM. And so most of the industry is lined up around that at this point in time, from what I can tell. And so what we've got, though, is cybersecurity is in critical infrastructure. And in 2022, in the summer, there was a cybersecurity action plan for critical infrastructure that the Japanese government published in Japanese, and kindly enough, published also in English. And one of the challenges there that they've got for us is maintenance and promotion of the safety principles. Okay? So all of a sudden now we have safety and security trying to work hand in hand. And I don't know, hands up, how many people have worked with safety people? Okay, there's a few. How many of those safety people really want to see a vulnerability update? Okay, so we've got to change a whole paradigm here. We've got to make it easy for them to take the updates so we can stay secure even when things are safe. In particular, when things are safe, actually. So this was the first time I'd seen it mentioned in a security space, okay? There may be other places where they're expecting it, but it opened up a challenge, which is how are we going to do this at scale? And then last year, there was a cybersecurity bill of materials that came out from the FDA as a requirement. And here, they're talking about having an SBOM and the device information and related systems. And they're doing this because they care about safety. And so all of a sudden, it's not just the software, it's how the software is interacting with the hardware and with its environment. And so the question is, how are we going to get it so we can do cybersecurity at scale with this type of environment? And we're going to have to think about it. The other thing that came out last year was basically more expectations around the life cycle. The NTIA minimum elements did not have support life cycle, but it's pretty clear we need to know what level of support things are at, and then, quite frankly, when does it get end of life? And then if it's end of life, is someone going to replace it? Is there a logical follow-on? And so this is some of the things that I think you'll see the SBOM definitions evolve towards over time, but right now they're not. There are fields that are in various specs and various ways of doing it, but it's not part of the quote-unquote defined minimum. And then at the end of last year, we got this, after a whole bunch of panic through the year, we got this Cyber Resiliency Act out of Europe. And it is being very precise, again, about support periods. And they have quite a long support period in some cases. And so, this is going to be a challenge for the open source ecosystem, because we're used to basically just fixing things quickly and going on from there, but they're expecting things to be fixed for like 5 years, 10 years when they're being sold. 10 years, yeah. Okay, I got a hand up? Yeah. And so it's a question of like, okay, we're lucky if we can get like the Linux kernel, maintained for 2 years, right? And then, there's people who wants to, it's a business opportunity if someone can figure out a way of making it scale, but we aren't there right now. And certainly they are expecting SBOMs to be there, and so the transparency is going to be needed. And so these things are building themselves out. And, they explicitly mention SBOMs here, which is, it helps that transparency. And then, at the start of this year, we got the EU AI Act starting to show up on our radar. And they don't say the word SBOM, but a sufficiently detailed summary of the contents used on how this model is created is kind of like an SBOM to me when I read it, and provide all the information and elements, i.e. ingredients, to the downstream providers of high-risk AI systems so they can comply. So AI is bringing in the software and then the data sets and the application of the data sets to the software, and this is all provenance. And this is all going to be hitting us in the reality of open data sets even, but open software and how it all has been put together. Because vulnerabilities can happen in any of these places, or quite frankly, hazards. And we need to be able to, again, rationalize about safety. How many people in here have a Tesla? Okay, there's a few hands up. There's been a lot of recalls recently about updates and things like that. That's the interaction of some of the safety analysis, as well as the SBOMs and so forth, in terms of looking at sensors and what sensors are being looked at in order to make effective safe driving decisions for the autonomous car. So all of this stuff is emerging, and I don't think we're going to see it suddenly disappear. I think these are the areas we're going to have to focus on getting AI working well with the data sets and the models and the training, and be able to be transparent about that as well. So that's sort of giving a flavor for what's emerging. So right now, the whole big question is quality. What are these SBOM quality things about? Over the last year, we've gotten a lot of syntactic checkers out there. They check to make sure the fields are conformant to the specifications. It's meaningful information there, but there's a lot of things that are unknown unknowns. They're syntactically correct, but are they giving you useful information? So the semantics are still problematic. And things are, if you generate them during the builds and so forth, you're more accurate compared to analyzed after the fact. There's lots of academics, there's lots of vendors opining on what makes a quality SBOM, so there's a lot of different information out there. And different market segments have different expectations. Obviously, the FDA wants a support level. I've been chatting with the telecom folk. They have some different ideas. Same with the energy folk. So each of these supports, each of these verticals, and the regulatory authorities in these verticals is going to be weighing in. And in the CISA working group on formats and tooling, we've been trying to focus on, okay, what's pragmatic? How do you fill this in? What's the expectation? And that was missing. And there's a lot of discussion on the word, how do you fill in a supplier, right? We think that's straightforward, but it's not. And this is part of what we need to do to sort of normalize all this information. And these are requirements that are, coming in. So the risk management, the legal risk is still there. Operation management, export control, cybersecurity, the crypto, bill of materials, what sort of crypto algorithms are being used, what sort of safety analysis and profile management. All of these are things that are coming in, so what the needs are, these are going to, are how do we manage product lines over time? You just don't put an SBOM out and you're done. You've got an SBOM for your system, it's got a patch update. You want to keep that. Oh, it's got a dependency that's been replaced. Oh, we're going to need to make sure that keeps kept up to date. You're not going to be regenerating these whole things. We need to start working with these things as databases and having relationships that link, so you always can know what the state is at a point in time and at another historical point in time. We're going to need to get to that level of flexibility. We need international standards. Our supply chains are not just in one country. They're worldwide, so we're going to need to be able to talk to each other across boundaries. And we need to have better indicators of quality, as well as, how do we support products? And I guess, as I've been sort of showing with the safety side, we have to look at systems. So that's also hardware, services, operational information, beyond just the software. So you're going to be seeing things emerge this way, and people want to start sharing this data so they don't have to keep redoing it, so open frameworks are going to be needed here too. So these are some of the needs we're sort of seeing emerge. We don't have solutions for them all, but we're trying to work towards them. Some of one was a white paper that came out of the CISA group, which is assembling a group of products. We were basically having medical device manufacturers saying, I've got the SBOM for this component, I've got this SBOM for this component, but my product has both of them in. What do I put in? Well, okay. You put in a top-level product line BOM about it, okay? And so, this white paper there, if you're interested in this problem, it's there, it's a starting point. The NTI minimum fields, we've had them in SPDX2. Since there's a checklist that you can validate, you've got your valid SPDX. And so this is things that, we put this into an international standard, and we're continuing to evolve it. So the nice thing about the SPDX framework is it lets us go down to the source levels and beyond, which for certain vulnerabilities is going to be needed. And quite frankly, for the safety use cases, we have to take it to the source level, because you have to know exactly which files are put into your safety use case, as well as your builds. Now, there's already 2 projects. The Octo project has been doing this now for a couple of years, as has the Zephyr project, automatically on builds. And the Octo project's also doing it for the toolchain that does the builds. So this is things that the safety cases are looking for. So we've got projects out there that are already doing this today. And people can, take a look at what they're doing, and they're going to be evolving into some of the new stuff coming out of SPDX3 as well. So improving these systems and improving these transparency is going to be a key theme, I think, in the years to come. We've just putting out SPDX. The model was tagged last night for SPDX 3.0, finally. Yes. And the spec should have its tag on it today. So you'll be seeing things a little showing up that way. But we focused a lot of the changes in there for security, okay? People wanted to use an SPX docs to convey security and critical information instruction. The AI, ML, and the data sets, and tracing that provenance and the interaction of that provenance, we have a very rich set of information there. We've worked with the IEEE and their AI ethics groups to make sure all the things they wanted to catch in their specs can be represented here. And we are looking, obviously, at some of the stuff that's emerging out of the EU and the US. And quite frankly, for safety, we need build provenance. So this is sitting here, too. So we did a lot of work over the last few years and trying to make it simple so you can only work in profiles. So if you care only about VEX documents and security, you can just do that. If you care only about licensing, you can just do that. But if you care about all of them, you can have ways of specifying the information your tool needs to generate or accept and read. So the relationships have been enhanced significantly to basically let you start to create that metadata knowledge graph in those databases. And that's what's going to let us scale modularity over time. So these 4 bottom ones here are the same functionality that we have already in 2.2. And then we've added profiles for data, AI, build, and security. So there's a lot more information out there now and a lot more fields to use in a standard fashion so you can basically refer from one to another and, quite frankly, start to tackle this problem here, which is the maintenance and promotion of the safety principles and be able to be reasoning about it. Because one of the things we recognized 2 years ago was the safety standards are looking for things that are in an SBOM plus a bit more. And so you'll be seeing more emerging that way. So beyond it, we're starting to work on the safety critical applications, and we're prototyping things right now. We'll be learning what we don't know out of the AI and data set side. And one of the areas that is a big gap right now, CISA put out a document last year on the hardware bill of materials. The trouble is they were very physical. And we don't have any virtual twin support, FPGA support. So we're working on making sure we can express that. And then we're going on beyond operations and usage. So the services profile, it's been working. There's groups working on this. There's groups working on the hardware profile. If someone's interested in this area, please come talk to me, because we want to make sure we can do the digital twins properly and the virtual environments properly. And then we're also working on the operations, and that's where we've got export control. The cryptographic usage is also important there, and we're targeting the release to 3.1. So these are all working groups that are active and have been active now for several months, if not years. And so if you're interested in any of these areas, you're definitely welcome to come participate. With that, I just want to say thank you to all of our SPDX supporters who've been participating in us actually pulling this all together. And if you want more information on the SPDX stuff, check out our new website. And these green groups are open to all. You don't have to sign up. And we have our meeting stuff up on GitHub. So with that, I'll say thank you.